Hi everyone, welcome to Math 105. In this tutorial, I'm going to take us through an overview of the topic matrix. Matrix. So what is matrix? Matrix is simply defined as an array of numbers in rows and columns. In rows and columns. For example, this is a matrix 2, 1, 3, 1, 5, 2, enclosed in a curved bracket. So in this matrix, the numbers you see that are arranged in the horizontal form, they form the row of the matrix. So in this case, there are 2 rows. So the first row, then the second row. While the numbers that are arranged vertically downward form the columns of the matrix. The columns of the matrix. So this is column. So the vertical numbers form the column. So in this case, there are 3 columns. So this is an example of matrix, and it has rows and it has columns as well. Other examples of matrices are this. You can have 2, 1, 3, 2, for example, just an example. 7, 9, enclosed in a curved bracket. So in this case, you see that there are 1, 2, 3. That's 3 rows. And the columns you see here, we have 1, 1, 2. The vertical numbers, the numbers arranged vertically, form the columns. So there are 2 columns here. And that brings us to what we call dimensions of matrices. When we talk about dimensions of matrices, it's simply the row by the column. It takes a format. So the dimension of every matrix is obtained by doing the number of the rows by, this is times, we call it by, when we're dealing with matrix, the column. Okay, so the row by the column form the dimension of the matrix. Looking at this example we have here, there are how many rows here? 1, 2, 3. So we say that the dimension of this matrix is simply 3 by 2 because there are 2 columns. So this is a 3 by 2 matrix, and the one above here is a 2 by 3 matrix. Okay, so this is basically what matrix is. It's simply an array of number. When we say array, arrangement of numbers in rows and columns. Very simple. And this brings us to what is called the position now of matrices. So the position of the elements in a matrix is very, very important. Now, if you look at this matrix, you will see a number here. You see a 2, you see a 1, you see a 3, you see a 2, you see a 7, and then a 9. Each of the numbers you see inside this matrix is called an element. Each number in a matrix is called an element. An element. So there are 6 elements in this matrix. And coincidentally, in this former one, there are also 6 elements in this matrix. Okay, so how do we represent the position of each element? And that's what we're going to do now. Let's look at this, for example, now. Okay, before we talk about that, let's finalize on the dimensions of the matrix. Let's look at this now. More examples. If we have 2, 3, 9, 1, 4, 1, 3, 2, what is the dimension of this matrix? This is obviously, if you can guess, it's obviously a 2 by 1, 2, 3, 4. A 2 by 4 matrix. Another example, you can have 4, 5, 3, 0. It has 4 elements, so this is a 2 by 2 matrix, 2 by 2 matrix. Okay, so that's about the dimensions of matrices. Now I want to talk about the positions, how to position or how to identify an element by position in a matrix. Very, very important. Now, let's say we have an unknown matrix, okay, such that the first element is represented by 1, 1. The second element is A, 1, 2, and the third one is A, 1, 3. You see, these numbers at the bottom here, these subscripts, what do they mean? The first number here is what represents the number of rows that this element lies on. For instance, if we have, let's say, A21, A21 means that this element here, whatever the element is, this is a number, any number. It means it's in the second row. It's in the second row and the first column. The first column. So that's how you identify the position. Like, look at this one now. This number you see here, this element A11 is in the first row and the first column. This is in the first row and the second column. This is in first row and the third column. So similarly, we can also have something like this. A11, A12, A13. Now we're moving to the second row now. So we're going to start with 2. A2, 1. That's A21 means this element is in the second row, but in the first column. So the next is going to be A22, second row, second column. As you can see, this is the second column, and this is the second row as well. And then we have A23. The same second row, this very element is in the second row. As you can see, it's on the second row, but in the third column. So we have another element. Let's say, so this is going to be A. What row is this? Now this is the third row and the first column, A31. Just try to understand this. Take your time and look through this. It's actually very simple. Okay, so A31, A3, that's third row, second column, and then a third row, third column. So that's how you identify the elements of a matrix, okay, by the position. Now, if we take a look at this matrix, for instance, let's say 10, 2, 0, 1, 4 minus 2 in the bracket. What is the position of this element here? So this is always A11. So the first element is in A11. This is A12. The next one, 0 here, is in A21, meaning it's in the second row, but in the first column. Second row, first column. Second row, first column. So that's how you identify the positions of the elements in the matrix. If you look at your own materials, the one that have been sent to you, you look through it, you see exactly the same thing there. But I think they've used X for the elements. So if you're using X in place of A, take note, these A's you see here, they are the elements. Okay, just represent something like 10, 0, 1, 2, 4, minus 2. So that's what it is. So if we're going to be using X for all of these, that means we'll have X11 x, 1, 2, and then x, 1, 3. All this 1 you see here represents the first row. And then the next row, which is the second row, it will now take 2, 2, 2. The first numbers representing the rows in which that element lies. And of course, this is what now? What column is this? This is the first column. This is the second column. That's 2. This is the third column, and so on. So it doesn't matter whether we're using X or A or B or whatever we're using. So that's how you represent elements of a matrix by these denotions. Okay, so this brings us to types of matrix. There are different types of matrices. We have all manner of matrices, but then they are all very, very simple to understand. And I'm going to take you through each of the various types of matrices. They are simple, like I said. Okay, so types of matrix. Types of matrix. Types of matrix. There are different types of matrices. The first one I'm going to talk about now is called the row matrix. The row matrix. All these types of everything we are doing here is in your material. So when we are done with this overview, you should go through your material. It will be easier for you to understand in that way. Just going through this video, going through the lesson without going through your material is not really going to help. Okay, but it just will give you an overview, and you need to also do further work to make the course much more easier for you to understand. Okay, so the first here, we're going to talk about the row matrix. The row matrix is just simply a type of matrix that has just one row. For example, 2, 1, 5, 6. Doesn't matter how many elements you have on a row. So this is just a row matrix, or you can call it a 1 by 4 matrix. That's the dimensional. So 1 row, 4 columns. So it's a row matrix. That's an example. Another example of a row matrix, you can have something like 2, 3. Just a row. So this is what now? This is 1 by 2. So this is what a row matrix is. It's a matrix that has just one row. And then we have what we call the column matrix. So you're going to be taking note of all these types of matrix. Now, this video is just to, it's not, you are watching this video because when we meet in our class, it's going to make things really easier for you. So take your time to go through. If you have questions, do well to put them down so that when we meet, you can always ask your questions. Okay, so the column matrix. The column matrix is another type of matrix. As the name implies, just like the former one, it's a type of matrix that has just one column. Okay, the column matrix has just one column. Example, you can see this 2, 1, 5, for example. This is an example of a column matrix. How many rows are here? 1, 2, 3. So the dimension of this matrix is 3 by 1. Just one column. This is a column matrix. So when you see this type of matrix, you'll be able to identify it as a column matrix. Very easy to understand. And the next is called a number 3. That's number 2. So number 3 is called a rectangular matrix. We have a rectangular matrix. All right. A rectangular matrix. So a rectangular matrix is a type of matrix in which the row number and the column numbers are different. For example, you have let's say 5, 0, 1, 2, 1, 6, for instance. The row number and the column numbers are not the same. Like you check the dimension of this matrix, you will see that this is a 2 by 3. The row is 2, the column is 3, and so the rows and the columns are not the same. Okay, so this is called a rectangular matrix. Like if you check, it just takes the shape of a rectangle, just like this. It's a rectangle, or it can even be like this. Probably the rectangle will be standing like this. So in any form, a rectangular matrix has both the row and the column to be different. Another example of a rectangular matrix is this. So you can have something like, let's say 4, 1, 2, 3, 1, 6. Okay. So this is also a rectangular matrix because the number of rows here, we have 2 rows. Am I correct? 1, 2, 3. Yeah. 3 rows and 1, 2, 2 column. So the dimension of this matrix is 3 by 2. Why this is 2 by 3. Okay. Technically, we can even refer to the column matrix as a rectangular matrix, as you can see. Okay, because the dimensions are not the same. I mean, the row and the column, they are not the same, the rows. Okay, so that's what the rectangular matrix is all about. Rows and columns are different. The next type of matrix now, following the rectangular, as the name implies, we're going to look at what we call the square matrix. Very, very important. The square matrix is very important when we're in the study of matrix. As we study matrix, square matrix is very, very, very important. Now, what is a square matrix? That's number 4 now. Number 4. What is a square? A square matrix. A square matrix, very simple. I believe you all know what a square is. A square is like this, often like this. A square has all 4 sides to be equal. So what it means is any type of matrix in which the number of row, I don't know, I keep using 2, doesn't matter. Okay, number of row is equal to the number of column. That matrix is called a square matrix. So this is a 2 by 2 matrix. So you can see that the row and the columns are the same. So it's called a square matrix. Both rows and columns are equal. Okay, so we can even have a 4 by 4 matrix. We can have a 3 by 3. Let's do it 3 by 3. 1, 0, 0, minus 2, minus 3, okay, minus 9, 1, 5. So this is another square matrix, and the dimension of this matrix, simply, this is a 3 by 3 matrix. Okay, so the row and the columns are the same, so it's called a square matrix. I'm just trying to give you an overview so that when we meet in the class again, things will be easier for you to understand. Okay, so the next type of matrix we're going to look at now is called the zero matrix. So what is a zero matrix? The zero matrix is simply a type of matrix in which all the elements are 0. So number 5, we'll have the 0 or the null matrix. You can also call it the void matrix. So 0 or null or the void. When you say something is void, it's empty. That means nothing is inside. So a zero matrix is a type of matrix in which all the elements are 0. It can be a 2 by 2, it can be a 3 by 3, 4 by 4, whatever the case may be, 2 by 1, 2 by 9. All the elements are 0. Let's add one more. So this is called a null matrix. Okay. And then we have what we call the identity matrix. An identity matrix is the type of matrix in which, as number 6, the elements in the main diagonal are just 1. So the identity matrix. The identity matrix. For example, all the elements in the main diagonals are 0. An example, a quick example of an identity matrix is, let's say, 0. Okay, so I have 1 here, 0 here, 1 here. You can see that the diagonal, you see that this diagonal here, all the elements are 1. That's called identity matrix. Okay. Another example, you can have 1, 1, 1. Okay, 0, 0, 0. Where do I have a 0? We have a 0 here. We have a 0 here. We have a 0 here. Good. You check the main diagonal. If you check the main diagonal like this, all the elements there, 1, 1, 1, 1, 1. So if it's 1, 1, 1, it's called an identity matrix. Okay, and then we have what we call the diagonal matrix, which is also very easy. All the elements in the diagonal this time, they are yes, they are not 1 this time, but every other element is still 0. So that gives you the diagonal matrix. So you can check your materials, go through your materials, you learn more from it. Okay, this is just to give you a quick overview of the topic. So we want me to discuss in depth. Okay, so number 7, we have the diagonal matrix. Diagonal. Sorry about the camera. Diagonal is so blurry. Well, okay, I don't know why it's appearing blurry. So the diagonal matrix. Okay, this is blurry. Okay, diagonal matrix. Why is this thing blurry? Okay. So in the diagonal matrix, the elements in the diagonal are different. So an example, 1, okay, let me go with 4, 2, 9. You have a 0, 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 and then you have a 0. Where is the diagonal? You can see here that if you don't understand, you can go through from the beginning, take your time, to get this. It's very, very important to understand this, because the last thing you want to get in this course is anything less than A. It's a very simple course, so you're going to follow through carefully. The good thing is that the time for this lesson is flexible. Evening, when you're back from your daily activities, you can take your time to settle in and do this. Okay, so the main diagonal you see here, the elements are not 1. So it's called a diagonal matrix. And every other element you see there are 0. So this is called a diagonal matrix. Now, we equally have other types of matrix. We call them the special types of matrix. And I'm going to show you that now. The special types of matrices. Special types of matrices. Now, the very first one under this is called the transpose of a matrix. The transpose, sorry, I write in cursive, the transpose, try to understand. Transpose of a matrix or transpose matrix, transpose matrix. Okay, so the transpose of a matrix is simply obtained when we change the row of that matrix to column or the column to row. For example, if I have the matrix, a given matrix as, I didn't even tell you, we normally represent matrices with capital letters, okay? Matrices are often represented with capital letters. They don't just stand alone. For example, we could have said earlier that this is a matrix such as X, for example, equal to this. Okay, so let's say the matrix A is given by 4, 1, 0, 2. Okay, this is a matrix, for example, and then we want to transpose this matrix. To transpose this matrix, the new matrix becomes A to power T. That's A transpose. That's the transpose of the matrix A. And how do we get the transpose of a matrix? It's very simple. All you need to do is to make the rows to be the column. So the row here, the first row you see here becomes the column in the new matrix. The row becomes the column. The row becomes the column of the new matrix. So the row here is 4, 1. So we're going to make it the column now. 4, 1. So I've made the row here to be the column. We'll do the same thing to the next. The next row becomes the next column. So here we're going to have 0, 2. So what have we done? We have already transposed the matrix A to the matrix AT. Okay. So in the same way, we can transpose a 3 by 3 matrix. Let's say we have the matrix P equals 1, 5, 2, 0, 8, 9, minus 1, minus 2. You You can even have a fraction there. Take note. It's okay to have a fraction there. Okay. Okay. In a bracket, we can choose to transpose the matrix P. We can transpose the matrix P to get PT as the transpose of matrix P. So let's transpose this matrix now. The first row here is 1, 5, 2, so it's going to become the column now. So we're going to write 1, 5, 2. The transpose again of a matrix is simply making the rows, making each of them to become the column in the next matrix. So 1, 5, 2, 1, 5, 2. Then next is 0, 8, 9. So we're going to have 0, 8, 9, and we have -1, -2, and 1/2. -1, -2, and 1/2. Okay, so we've transposed the matrix P to be this now. That's this now. So this is how you transpose a given matrix. So the next thing we're going to talk about now is what we call the symmetric matrix. The symmetric matrix. So all of these things are in your handout. So you go through them step by step, just giving you overview. Then we'll discuss what meet in the class. Now, the symmetric matrix, that's number 2 under the special type of matrix. Number 2. Okay, it's called the symmetric matrix. The symmetric matrix. The symmetric matrix. What is a symmetric matrix? This is simple. It's a type of matrix in which the transpose of the matrix itself equals the matrix. Okay, there are some matrices that you transpose, you discover that their transpose is the same thing as them. So a type of matrix, let me write this down, a type of matrix in which the transpose equals the matrix itself. The matrix itself. An example of such matrix, which matrix is that we can transpose? Let's say we have the matrix A equals, okay, let's say, okay, I'll just give an example, 2, 3, okay, and I think 3, 2. Yeah, this should work. 2, 3. 2, 3, 3, 2. Yeah, this should work. Let's transpose this matrix and see. Just trying to create a matrix that is symmetric. So let's transpose this matrix and see. A transpose, we'll transpose this. 2, 3 becomes the what now? 2, 3. 2, 3 is the row. So we'll transpose 2, 3 becomes the column here. Then what do we have here now? This one again becomes 0. Yeah, that's it. 3, 2. Okay, 3. That's the row for the second matrix. The second row of the first matrix, which is this now, that's 3, 2. Okay, so if you check the transpose of the matrix, okay, so what do we have here? We have 2, 3, 3, 2, 2, 3, 3, 2. So you can see that the transpose of this matrix is the same thing as the matrix itself. So such matrices are called symmetric matrix. When you transpose a given matrix and the result of the transpose is the same thing as the original matrix, that is called a symmetric matrix. Okay, so forgot to cross the T here. So okay, so in that case, we can define this mathematically as a matrix that is equal to its transpose. So this is the definition, mathematical definition of a symmetric matrix. A matrix whose transpose is the same as the original matrix. And the next here is, we're going to talk about number 3. It's called the singular matrix. The singular matrix, blurry. The singular matrix. What is singular matrix? Is a type of matrix in which the determinant is equal to 0. Okay, so I'm not talking about we're not talking about determinant now. We'll talk about this in our next lesson, or maybe in the course of the class tomorrow. Okay, as at the time of this recording. Okay, so okay, let me give you an example of matrix. Let's say the matrix Y equals 7, 1, and 7, 1. Okay, 7, 1, 7, 1. Yes, this works quite all right. Or you can even say 7, 4, 7, 4. Doesn't matter. Okay, so if you look, this is called a singular matrix because the determinant will be 0. The determinant of a matrix, which is what we're going to, I said earlier, is denoted by, if we're talking about the determinant of the matrix Y, is represented like this. This, this determinant, or you can do that Y. That's the determinant of the matrix Y. Okay, and it's often calculated by multiplying the trailing diagonals and subtracting with the leading diagonals. Okay, so the matrix we have here, for example, we have 7. Okay, so the determinant of this matrix Y is just calculated by doing this times this. Okay, that's the leading diagonal minus the trailing diagonal. So 7 times 4. We're going to talk about calculating determinant of matrix later. Maybe, I don't know. If we do well with time, we can do it in this lesson, but let's see how it goes. Minus the product of these two. 7 times 4 again. Okay, so if we subtract this 28, take away 28, and that gives us exactly 0. So we refer to the matrix 7, 4, 7, 4 as a singular matrix. Why? Because the determinant of this matrix is 0. And next we have what we call the orthogonal matrix. Orthogonal matrix. Orthogonal matrix is another type of matrix for orthogonal matrix. This is the type of matrix in which the transpose is equal to the inverse. So if the transpose of a matrix equals the inverse of that matrix is called orthogonal. I'm not going to go into this now because calculating the inverse of this is going to take us a little while. Okay, so it's a topic for another day. In the course of this module, this module 1 of your 100 level, of course, it's part of what we're going to talk about, but not today. Okay, so that's orthogonal matrix. Just take note of this. We'll refer to this later on. And then number 5, we have the inverse of a matrix, the inverse matrix, which is still the same thing. Okay, we'll talk about the inverse of a matrix later. Inverse of a 2 by 2, inverse of a 3 by 3 matrix, and all that. Okay, so the inverse of a matrix, okay, is just if B is a matrix, then the inverse of the matrix B is B raised to the power minus 1. So this means the inverse of the matrix B. Okay, and second to the last, we have what we call the upper triangular matrix. These are types of matrices in your handout, so just look carefully. Upper triangular matrix. Upper triangular matrix. A very simple type of matrix. I won't waste time on this. The upper triangular matrix is a type of matrix in which all the elements below all elements below the main diagonal. Let me put it that way now. All elements below the main diagonal, all elements are 0. For example, if you look at this, let's say 2, 9, 7, we'll have a 0 here. Sorry, 4, 1, we'll have a 2 here. We'll have a 0 here, we'll have a 0 here, we'll have a 0 here. This is called upper, let's take note, this is 4. This is called upper triangular matrix. Why is it called upper triangular matrix? Because all the elements below the main diagonal are 0. So if all the elements below the main diagonals, below the main diagonal are 0, then it's called upper triangular matrix. Because you can see a triangle that is above, like this, upper triangular matrix. Okay, another example, you can have something like 2, 9, let's say 4, and then you have the 0. This is a 2 by 2 matrix, but it's also an upper triangular matrix because you check, this is the main diagonal, and any other element below the main diagonal is 0. So it forms a triangle that is above the 0 you see there. So that's upper triangular matrix. And then we will have the lower triangular matrix, which is the last type of matrix we're going to look at now. Okay, so this is upper triangular. Then we'll look at the lower triangular matrix. Number 4. Number 7. I'm going to go with the blue pen. Take a blue pen. Number 7. The lower triangular matrix. Lower triangular matrix. Lower triangular matrix. Triangular matrix. Sorry about that noise. Okay. So the lower triangular matrix is the same thing as the former one, just that the triangle will be at the lower part. That means all the elements above the main diagonal will be 0. So in that case, we can form one. Let's say we have the matrix H equals 1, 2, 9, 4. Let's mix it up now. The 4 should be here. Let's say we have 6 and we have 2 here. And now we're going to have a 0 here, a 0 here, and a 0 here. Good. This is another example of a lower triangular matrix. Although this is not in your handout, but you need to just know what this is. So you look above the main diagonal. You have all other elements there as 0. So you have the triangle below this time. So this is called a lower triangular matrix. Okay, now the last thing we're going to talk about in this video is called the equality of matrices. Equality of matrices. Equality of matrices. Equality of, this is C, matrices. So equality of matrices, we can say that two matrices are equal when the corresponding elements are equal. All right, so we're going to take that again. Two or more matrices are said to be equal. Two matrices are said to be equal, all right, if the corresponding elements are equal. Okay, so this is the last thing we're going to talk about in this tutorial. Let's say we have the matrix B equals 2, 8, 1, 7, 9, 2, 1, 5, 0. All right. And then we have another matrix Q equals X, 2, Y. Okay, X2, Y. X2, Y. A. 7K, and then P 9. Okay, yes, 9 already, so here has to be 9. Let me just say 9 here. 9 here has to be 8. Let's say I have M here. M. Okay, M, we have 5 already. 5 and 0. Okay, so if we say that matrices B and Q are equal, then the corresponding elements are also equal. So two matrices are said to be equal if the corresponding elements are equal. So if they ask you to either say B is equal to this and Q equal to this, and both matrices are equal, then by implication, we can easily find the value of X. And that implies that X is obviously 2 correspondingly, since the two matrices are equal. Okay, similarly, M is equal to 8. They're in corresponding positions. And Y is equal to 1. Y equals 1. And A here is equal to 9. You can see A equals 9. Correspondingly, this is A now. A equals 7. A equals 7. And here's 9 already, so here's 9. That's because they're corresponding. And 2 equals K, or K equals 2. K equals 2, and so on. P equals 1. P equals 1. So 5 is here, 5 is here. 0 is here, 0 is also here. So this is the idea of equality of matrix. You can use this principle to solve linear equations involving all kinds of variables and all of that. All right, thank you very much for watching. If you don't get this quite all right, okay, so feel free to go through the video again and make sure you understand everything before we meet in the next class. All right, until we see you then, bye.